And welcome back to Mr. Gregorius Math. Today we're taking a look at some similar triangles word problems. So we have a couple of different word problems we've been working with as a class. One of them is mirror, mirror on the floor. Another one is a river runs through it. And this is a river runs through it type word problem. So perhaps we've got a river that runs along the board here between points E and D, and we have a triangle set up. So perhaps we know all the measurements on one side because we're able to actually stand on that one side of the river. And our question is, what is the width of the river? So what is the distance from E to D? Well, the way that we're going to do this is by actually measuring with a set of right triangles, or rather a set of similar triangles. So we have to make some statements here. First off, I have to assume that these are right triangles, and that probably would have been information that was given to me in the lead up to the question. So I have to prove that triangle ABC is similar to triangle CDE. And the way that I do that is by stating angle B is equal to angle D is equal to 90 degrees because it was given. So that piece of information was given to me, and so there's no need for me to go ahead and try to tax it out or figure out a way to get there. It was given to me. Now the other piece of information that's given is, notice these angles are directly one across from the other. Now in Mr. Marshall's class, this would have been referred to as starship. However, we'll refer to it as the opposite angle theorem. And so we can state that angle BCA is equal to angle ECD. So angle BCA is equal to angle ECD. And that's by opposite angles. And once I have two angles are equal in my triangles, then that means that I've got a set of similar triangles. So I can make the statement that triangle ABC is similar to triangle EDC. So I have to make sure to start from the corresponding points. So A corresponds with point E, B corresponds with point D, and C corresponds with C. And that's the reason why I have my triangles listed in that way. Once I've made that conclusion, I can go ahead and set up a ratio of missing side lengths. But I've put a little twist in this example that my class perhaps hasn't seen yet. So I'm going to start writing the ratio that would go along with this similar triangle. So I'll start with my unknown, my variable W, because that's the thing that I want to find. And I know I can stay within the same triangle and write my first ratio as W over 15. But now I have to go and find the corresponding side length that goes along with that. Well, here I would have 3 corresponding with W. But notice how 15 is the side length DC. So that means I need to know side length BC, which is right here. And I don't know side length BC. So I think first I'm going to have to find it. So this looks like it's a right triangle, and I have two other measurements. So I've got a squared plus b squared is equal to c squared. My hypotenuse is 5. And if you're already pretty sharp with your Pythagorean triples, you'd recognize that this is going to work out to be 4. So I'll have 3 squared plus b squared is equal to 5 squared. So I'll have 9 plus b squared is equal to 25. Subtracting 9 gives me b squared equals 16. And hence b is equal to 4. And so I now know that measurement there is 4, which is good because it corresponds with my 15. Lastly, now that I've set up my ratio, all I need to do is solve. So I need to get W alone, so I'll multiply both sides by 15. In doing so, they cancel. Neat, neat. So throw out to Mr. Odekirk. And 3 times 15 is 45. 45 divided by 4 is going to be, I guess, 11 1/4. And so we now know the width of the river. The width of the river is 11.25, and whatever the units were, whether it was meters or not. Don't forget to hit like, subscribe, and ring that notification bell. Do check the comments, which have been turned off, so they'll say nothing. So if someone wanted to say first, they wouldn't be able to. But do check the comments and the description for the link to the merch store. And a shout out to my fantastic videographer, I can't say names, GR? GR. Awesome. Take care.